Welcome back to another Make Math Make Sense Master Math Classic Math video brought to you by your host, Shalongo. Today we're in the Algebra 2 course in the Complex Numbers unit, going over powers of the imaginary unit skill, exercise, skill, whatever you want to call it. Before we start, I'd encourage my users to pause and review this note page. Powers of the imaginary unit simplifies all of this in some brilliantly eloquent words to help you understand what this pattern is, but if you choose not to look at it, totally up to you. Let's go ahead and get in the first problem. Question number 1. Which of the following is equivalent to the complex number I to the 36th power? In order to understand this and really understand this lesson, you've got to understand the concept. And I'm going to go ahead and explain this concept right now, and it'll be a little time consuming up front, right? And so we've got I, and we know what I equals. We know I equals -1. There's a pattern with I in its powers, right? And this pattern is essentially, we've got I squared, we've got I to the third, and then we've got I to the fourth. So all 4 of these have different values, all represent different values. And then I to the fifth, the value that I to the fifth represents is the same value that I represents, so they're actually equivalent. So I to the fifth and I are the same thing. I to the sixth is the same thing as I squared, I to the seventh is the same thing as I to the third, and I to the eighth is the same thing as I to the fourth. And then again, if I was to continue the pattern, I to the ninth would be the same thing as I to the fifth, which is the same thing as I. Right? So there's a pattern here. I want you to understand the pattern. So we know that I is the square root of -1. So let's consider what I squared is. I squared equals I times I, right? This is when you multiply bases, you add up the exponent. I'm working backwards here using the sum rule for exponents, right? I squared is I times I. And we know that I is the square root of -1. So if we take I squared, we're really just taking the square root of -1 squared, right? And we can rewrite this as actually -1 to the 1/2 power squared, because they're the same things. The square root of -1 and -1 to the 1/2 power are the same thing. Let's pause this for 1 second, right? So let's take the square root of 4. We know that is 2. Let's take 4 to the 1/2 power. We know that is 2. So I'm just proving to you that these two things are the same thing, right? If we take square root of 81, we get 9. If we take 81 to the 1/2 power, we also get 9. So I'm just rewriting it in a way that is equivalent. So now that I've done that, we actually have a power rule here, right? We've got the power rule. We can use the power rule. Let's use the power rule. No space to write. I've cleared some space to write the power rule. So when you have exponents taken to other exponents, like we do, we have -1 to the 1/2 power to the second power, we can use the power rule, which essentially is, if we have x to the a power, I'm having trouble writing right now, and we take that to the b power, we've got a being taken to the b power, we can rewrite this as x to the a times b power. So the power rule says that we can multiply exponents when we're taking them to we can multiply the exponents to simplify them. Alright, so let's do that. We've got -1 to the 1/2 power times 2. Okay, and now we're just multiplying fractions. Multiply the numerators together. We get 1 times 2 is 2, and then we have 2 times 1 is 2, right? And so we've got -1 to the 2 over 2 power, and we know that 2 divided by 2 is 1. So we got -1 to the 1 power, and anything to the 1 power is itself, so we got -1. So I squared, if I is -1 is the same thing as the square root of -1, then I squared is the same thing as -1. Those are the same exact thing. So let's consider I to the third power. I to the third power is the same thing as I squared times I. And we know that I squared is -1. And we know that I is the square root of -1. And if we multiply those together, we get -1 times the square root of -1. And then we can just rewrite this as negative square root of -1, which is the same thing as just -I, right? And that should make sense to you, because here we have -1 is the same thing as I squared. Cool. That's the I squared part. Here's the I part. I is here. Boom, boom. And so I to the third power is essentially just I squared times I. And that gives us I to the third power, which I'll go ahead and use blue. Now let's consider I to the fourth power. I to the fourth power. We can rewrite this as, well, we can write this a lot of different ways, but let's think about it as I squared times I squared. Just think about it as that. I squared times I squared. Which is the same thing as -1 times -1. Well, we know what -1 times -1 is. It's +1. So I to the fourth power is actually the same thing as +1. +1. These are the same thing. I to the fourth power represents +1. So let's consider I to the fifth power. I to the fifth power is the same thing as I to the fourth power times I. I to the fourth power times I. Well, that's essentially the same thing as +1 times I, which is I. +1 times I is I. So I to the fifth power is the same thing as I. And this so on and so forth, right? I to the sixth power would be I squared. And this this pattern repeats. So essentially, we just got to figure out what value is I to the 36 the same as? Is it the same as I? Is it the same as I squared? Or is it the same as I to the third? Or is it the same as I to the fourth? Well, one way we could think about I to the 36th power is we could rewrite it, right? We could say, okay, I to the 36th power is I to the fourth times I to the fourth. That would give us 8 times I to the fourth would give us 12 times I to the fourth would give us, that would be 16 times I to the fourth would be 20. Here we got 24. Here we got 28. Here we got 32. And here we got 36. So we can rewrite this as I to the fourth times itself 1, 2, 3, 4, 5, 6, 7, 8, 9 times, right? Because we add all these 4s up. 4 plus 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 4 is going to give us I to the 36th power. Right? And so, well, since all these are I to the fourths, then we know that it's just going to be 1 times 1 times 1 times 1, so we know that it's 1. So that's one way we can think about it, right? Another way we think about it is, let's just go to Desmos. If we know there's a pattern that emerges from these, then let's go to Desmos and let's type in the exponent, 36. Let's divide it by 4. If it comes back as a whole number, then it's got to be I to the fourth power, which means it's got to equal 1, right? If it comes back as, let's say, 33 divided by 4, if it comes back as a decimal, no, let's go 35, because 35 we know is going to be, if I to the 36th is the same thing as I to the fourth, and then we know that I to the 35 is going to be the same thing as I to the third. If it comes back as 0.75, then we know it's the third, it's got a remainder of 3, cool, third power, right? If we put in I to the 34th, it comes back as a half, 2, remainder of 2, we know it's I to the second power. And if it comes back as a remainder of 1, which would be I to the 33rd, we got it. Okay, so the first power. So let's rip through these. Using that strategy, right? Using that strategy. So here we had 36 divided by 4 came back as a whole. Cool. Whole means it's the fourth power. I have my little chart over here, right? So we want which of the following is equivalent to I to the 38th power? So let's take 38. Let's divide by 4. And it's got a remainder of 2, right? 0.5 is a remainder of 2. Cool, -1, done. When I say remainder of 2, you know what I'm saying, like 1/2, right? 1/2 is the same thing as 2, so maybe I add that in, right? I'm going to add that in my little note. Cool, if it comes back as 0.5, it goes with 2, right? If it comes back as 0.25, it's going to be just I. We're just trying to figure out what order in the progression is this coming. If it comes back as 0.75, then it's going to be I to the third. And if it comes back as whole, okay, then we know that's I to the fourth, right? So it came back as a 0.5, so I squared, right? 19th. 19 divided by 4. 19. 19 divided by 4. 0.75. That would be the third one in the progression. And that would be negative I. 17. 0.25. 0.25 is I. Boom, done. And that's kind of how powers of the imaginary unit work. We're just trying to figure out, given the exponent, all right, what pattern, what order does it come in our pattern? Is it the same as I? Is it the same as I squared, I to the third, or I to the fourth? Good luck.